Bam! Mr. Drew, if you have just learned about arithmetic sequences and partial sums, and you'd like to have a fun little challenge problem, pause the video and answer this question. Find the sum of the partial sum of 1 plus 3 plus 4 plus 6 plus 7 plus 9 plus 10 plus 12 up until you get to 46. What is the partial sum of this sequence? Now, I'm giving you a hint here. This is a question involving arithmetic sequences. So we have a sub n is equal to a sub 1 plus d times n minus 1. And you have, since this is a partial sum, there's no plus dot 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 after the 46. This is not an infinite sum. It's not a series. It's a partial sum. And our partial sum formula, S sub n, is equal to n over 2 times a sub 1 plus a sub n. Both of these formulas are going to need to be used to figure out the partial sum of this sequence, unless, because I'm not going to be accepting you just writing out all of these numbers and adding them up, which is technically going to work, but what if this goes out to the thousands and tens of thousands? We want to be able to find the partial sum using the formulas we've learned for our arithmetic sequences. Now, the reason why this was a fun question is because, well, if you go and start looking for that arithmetic pattern that I told you was in here, we have from 1 to 3, we have a plus 2. And from a 3 to 4, we have a plus 1. And then from 4 to 6, a plus 2, and another plus 1, and so on. So as we look at the numbers that are in this list, we do not have a constant difference. So how is this a problem about arithmetic sequences when we don't have a common difference between the terms in our partial sum? So how are we going to deal with this difference not being constant? Now, I know the process I'm about to walk through is not the only way of solving this problem because, well, I've had students solve it other ways. But what I'm going to propose for you to handle this problem, this fun little question about partial sums involving arithmetic sequences, is since we're adding 2, add 1, add 2, add 1, since that difference is not common, how about we look at this not as one partial sum, but 2. And handle the 3, 6, 9, and 12. And maybe some of you right now are hopefully going, oh. Now we're going to have to find the last term here. 3, 6, 9, 12. These are multiples of what? These are multiples of 3. So what is a number before 46? Because our partial sum is ending with 46. That is a multiple of 3. Well, 45. So this addition is going to go up to 45, which is, of course, a multiple of 3. And this is going to be one of the sequences, or series, excuse me. This is going to be one of the sequences for which we find the partial sum. And then we have a 1 to 4, 4 to 7, 7 to 10, and then up to our 46. So we are looking at another sequence, 1 plus 4 plus 7 plus 10 plus dot dot dot, hopefully adding up to 46 as our 2 arithmetic sequences. Because see, now with each of these, we have a plus 3, plus 3, plus 3, and so on. And for our other sort of half of this partial sum of our 1, 4, 7, and 10, we also have that common difference of 10. So here we have, let's see, we'll do it over here. We have a sub n is equal to 3 plus our common difference of 3 times n minus 1. And our last number, our a sub n, is actually equal to 45. And we're doing this because I need to figure out, now that we know the first term is 3 and our constant difference is also 3, and our last term is 45, we need to figure out what n is. I need to know how many terms are in this sequence so that we can, apply it to this s sub n is equal to n over 2 times a sub 1 plus a sub n. So we've got, subtracting 3, we have 42 is equal to 3n, distributing the 3, 3n minus 3. So we have 45 is equal to 3n after adding both sides by 3. And dividing by 3, we get that n is equal to 15. So good thing I color-coded this because I'm kind of like all over the place here. So our first red partial sum is, it's a sub n is equal to, again, that 3 plus 3 to the n, 3 times n minus 1. And now we also know that there are 15 numbers in that partial sum. For our second series that we pulled out of the original given problem, 1, 4, 7, 10, and so on up to 46, we know that a sub 1 is 1. We know that d is equal to 3. And our last number is 46. So using a sub n is equal to a sub 1 plus d times n minus 1, we have 46. Our last a sub n, our last value in this list, is equal to a sub 1, which is 1, plus our common difference of 3 times n minus 1. Subtract by 1 and multiply, distributing the 3 through the parentheses. We have 45 is equal to 3n minus 3. Add 3 to both sides, and we get 48 is equal to 3n. And dividing by 3, we get n is equal to 16. So our blue partial sum here, our blue sequence, our blue arithmetic sequence, has 16 numbers in it. So that's going to be a sub n is equal to, again, 1 plus 3 times n minus 1, where there are 16 numbers in that partial sum. And now we're just going to work out the partial sum formula s sub n twice, and I'll keep it color-coded. We have s sub 15 is equal to 15 over 2 times, for our red partial sum, we have a first term of 3, a last term of 45, which means we're looking at 15 over 2 times 46. 46 divided by 2 is 23. And 15 times 23, not right off the top of my head. Oh, yeah, good thing to check your answers. My last number here is 45, and for some reason I wrote 43. So let's try that again. 45. Now we got 15 over 2 times 48. 48 divided by 2 is going to be 24. And then 15 times 24, this time correctly, we've got 360. And for that 1, 4, 7, 10 going up to 46, our a sub n is 1 plus 3 times n minus 1, with 16 terms in that partial sum. We have s sub 16 is equal to 16 over 2 times a sub 1, which is 1, plus a sub n. I'll write it correctly this time, 46, which means we have 16 over 2 times 47. Okay, now we're not going to be able to do 47 divided by 2, but of course 16 divided by 2 is equal to 8. And 8 times 47, let's see here. 8 times 40 is 320. 8 times 7 is 56, so 320 and 56 is 376. And now to go back to our original question, what is the sum of 1 plus 3 plus 4 plus 6 plus 7 plus 9 all the way up to 46? Well, it's going to be 360 plus 376, or 736. And I'm Mr. True. Bam! Go to your homework or your test.